Everybody seem to be okay with it? Yes? Comfortable? Okay, so today I'm going to build on it a little bit. We're going to work with modulus functions again. I've showed you two different ways. Fifth period also guessed the wrong one for my favorite. I don't know why they don't think I like to square both sides, but who knows? So I'm going to also show you with inequalities, modulus functions. Okay. Do you remember last year when we started working with inequalities, what kind of technique we kind of built into that? The chart, right? I talked a little bit about that yesterday. So once again, with inequalities, there's a couple different ways to assess these problems. I'm going to show you both ways. You make the choice. On a personal level, I like to square them, but having said that, we'll go with it. So let's say 2x minus 5 modulus function less than 3. I'm going to go the good old-fashioned way, the kind I like to do first, just because, you know, I'm the ruler of the roost today. So we're going to square both sides, okay? So we're going to take this, and it's less than 3 squared. Are we cool? Feeling good? Yes. We're going to square both sides, FOIL it out, bring it all to one side, set it to 0. So we would have 4x squared, and then minus 20x plus 25. Today, my brain is working a little bit better mathematically, so we'll see. Okay, bring it all to one side. All right, how do we feel? Haven't lost anybody yet, right? Feeling good? Feeling good? Yeah. 25 minus 9 is 16. Yes, okay, good. Thank you. You guys are so sweet to me. What should I do with this thing? Divide by 4 for everything, right? So I would as well. So x squared minus 5x plus 4 is less than 0. Okay, now factor this puppy. So we have x, 4, 1, both negatives. I'm feeling good. And these guys are my critical numbers. What are my two special numbers that we see where signs change? So x equals what and x equals what? 1 and 4. Cool? So I like the chart because for me it gives me a visual of what's going on inequality-wise. I know what's positive, what's negative. So for those of you that didn't have me last year, I'm going to show you the chart. I think it's kind of a cool way to go. If you think of the chart as a continuum, my numbers that are special are the number 1 and the number 4. So I'm going to look at the stuff that is less than the number 1, the stuff that goes in between the number 1 and number 4, and then the stuff that's bigger than 4. So does that make sense, like a number line wise? Everything to the left, all the guys in the middle, and then all the stuff to the right. Okay? So in this instance, I pick a number that makes each of these particular statements true. What is something that's less than 1 that's a really easy number to play with? 0 works for me. Don't make it too hard on yourself, right? What's the number that falls between 1 and 4 that falls into this statement? 2 works for me as well, and then I would say 5. Sweet. Notice that the inequalities are always going to go in the direction that I wrote them there, because it's a continuum. The stuff to the left, between, and then the stuff to the right. So you're going to take this statement that I have written here, x minus 1 and then x minus 4 is less than 0. Literally, you're going to plug in the values that you just told me to write down and tell me, is this a true statement? Yes. Or is this a false statement? No. So I'm going to plug in 0. 0 minus 1, negative 1. You guys agree? So that's negative 1. 0 minus 4, negative 4. So negative 4, and that is a positive number. Is a positive number less than 0? No. So my answer here is no. Definitely is not part of my answer set. Is it hot in here or is it just me? Oh, whew. I thought it was just me getting old. Okay, plug in the 2. So 2 minus 1, positive 1. 2 minus 4, negative 2. It makes a negative answer. Is a negative answer less than 0? Sure is. My answer here is yes. And last but not least, plug in the 5 just to be safe. 5 goes in there. We got 5 minus 1 is positive 4. 5 minus 4 is positive, so there's my positive answer. The answer will be no. and I'm going to give you an old lady secret. If the answer is no here, it's going to flip to yes, then no. Always vice versa. If it's yes here, then no, then yes. Okay? So what is the answering set of this particular problem? Well, it's the stuff that made the yes happen. So the answers are between that and that. Yay. Right? So as promised, I showed you that I would give you the alternative. And the reason why I don't like the alternative is because you have two different techniques. If it's less than, you do it this way. If it's greater than, you do it this way. There's confusion that happens. But having said that, let me write it out. Hold on. So if the absolute value of something is less than or equal to b, it's going to go from negative b to a to the positive b. Okay, that's scenario 1. And then scenario 2 is going to be if the absolute value obviously is greater than or equal to b, it's going to be a is less than negative b, less than or equal to negative b, or, okay, a is greater than or equal to b. Okay, some of you might want to memorize that, might like this better. Let me show you how this works. When you find something, your modulus is less than or equal to b, right? So the scenario that I gave you here is a modulus was less than 3. That's the first case. Does that make sense? Modulus less than number. Are we cool? So how does that work? Well, you take the opposite of the number. So in this case, what was my number over there? It was a 3. You take the opposite of the number, put it here. You put the stuff of the modulus here, and then you put the positive of that number over there. So in actuality, this particular way is really pretty easy if you can memorize the technique. So if I'm looking at it, it's going to be negative 3 is less than, because it's just strictly less than, 2x minus 5 is less than 3. Now what do? You solve for x. Okay? So what would you do to all three components on this thing? First, does it make sense what I'm trying to say? I want to get x alone, so I'm going to add 5 to everything. Does that make sense? Add 5, add 5, add 5. So what do I get? Add 5. 2 is less than 2x, right, is less than 8. Are we cool? Yeah. Now what do I do to everything? For 2, what do I get? 1 is less than x is less than 4. What was the answer we got a second ago with my chart? Yeah. So why wouldn't I do that way every time? I get it. It's so much nicer, so much prettier. But what's the one thing that people do forget to do? To remember which one goes with this and then which one goes with this. Because if you think about it logically in the chart, if it's less than, it's going to be the stuff in between, right? And if it's greater than, it's going to be the stuff on the outside. Does that make sense? What I just said? So, are we cool? Which way do y'all like better? You like my chart? So, you would say that because you want an A, I know. I like visually the chart. It makes sense to me. But a lot of people are like, it's a no-brainer, Miss K. Why wouldn't I do this? You know? So, as with always, I want you to feel comfortable. Okay? But what happens when I throw this in the mix? Ready for the ACE kind of question, right? Okay. 2x minus 1 is greater than or equal to 3 minus x. Oh, how do we do it? Good question. I naturally know that to make something positive, always, what's my best bet? Is squaring it. I feel personal that I would rather square it. Because if I look at this and then I start to try to confuse myself with this, I'm like, I don't know where to go with it. So I'm squaring both sides. And squaring both sides is always going to get you where you need to get. So let's square both sides and let's see where I go with it. Okay. Play with the numbers. Have some fun. check my math. I'm pretty good today. I had one of those Starbucks coffees that has a lot of caffeine in it, so life is good right now. And I haven't really been slow at all today. Poor AS level kids are like, oh, what is wrong with this woman? She is on, speed 65 all day long. I'm like, yes, I am, because I had one of these. And I only had half of it. Can you imagine if I drank the whole thing? Whew. All right, what do we get? 3x squared plus 2x minus 8 is greater than or equal to 0. Check my math. Subtracted 1, added 6, subtracted 9. That's pretty. Now what? Factor this puppy, right? So if I factor it, you guys are really quiet. Is it because it's lunch and it's hot in here, or what? Tired of math already? Oh, can never be tired of math. All right, 4 and 2, I think. 4 and 2. 4 and 2. Yeah, 4 and 2. 4 and 2. I think that might do it. Positive 6. Yeah, that should do it. 3x squared, 6 minus 4 would be 2 minus 8. Yeah. So what are my two critical numbers on this thing? Negative 2 and 4/3. You feeling good about it? So I personally like to make the chart. I'm going to go erase this. And I'm going to create the chart with these. That's so lazy. I should have just written it all out again. Okay, so what are my special numbers? My special numbers are negative 2 and 4/3. What's the smaller number of the two? Negative 2. So I'm going to put a negative 2 here. Put a negative 2 here. What's my next number? 4/3, and plug it there. What's the only thing that I need to change that is a little different for this problem? Has an equal to involved, right? You see how the original has an equal to involved? So right over here in my chart, I'm just going to go this. Notice that the inequalities stay always in that same direction because it's a continuum. It's left to right. Okay, pick a number that's less than negative 2. Be nice to yourself. I would say that as well. How about this guy? 0 is beautiful. And over here, 1 is 1. This is 1 and 1/3, right? Yeah. I always kind of make it a decimal in my head so it wouldn't, All right, and I'm plugging it in. I always try to rewrite it for you so you see. Plugging it into the place that's already factored. 3x minus 4, and then x plus 2 greater than or equal to 0. So what is my little cheat method that will help us not have to work as hard?
Just
take one of them. Which one should I do? Start with 0, right? If it turns out to be yes, then what's the other two answers?
No.
Right? If it says no, then the other two answers are?
Yes.
Yeah, that's what I'm going to do. So this is negative, right? This is positive. That turns out to be a negative answer, which is not greater than 0. So that's a big no, right? And so what are the other two answers going to do for us? Yes. They're going to be yeses. So my answers are x is less than or equal to negative 2 or and whatever, 4/3. I think it's or they want to use is less than or equal to x. What do you think?
Miss Day,
Yes.
did you show us how the other method would work
I don't
in
even.
that scenario?
It takes it into it makes you graph.
Okay, that's what I was thinking. I was like, that doesn't
The
make
only
sense.
way you could do it is graph it. You would have to graph this guy, and then you would have to graph this guy. What do those things look like when you graph them, by the way? They're V's, right? So you would be looking for where these two guys connect, and then where the less than is. I think that's terrific.
I think that's, yeah. I just
Yeah.
didn't know if there was a way for us to.
There is not, there is no, yeah,
So you can only do the other method if one of the sides
a
isn't-
number,
Okay.
like a simple number.
Okay.
That's why I always rely on my squaring. It works every time, for everything. So, what do you guys think? Good?
Yeah.
Now we're gonna switch gears. I've worked with you guys on modulus function. Now we're going into division of polynomials. By far one of my favorite things. So, are we cool for me switching gears now?
Yeah.
Okay. Let's have some fun. Okay. We are going to practice two different types of division today. One is called long division. Haven't seen those words since 4th grade, right? Long division. And we're also going to practice something called synthetic division. Oh, I hear grunts and moans. This should be fun. Let me tell you the scenarios that make these work. I think this will be like, you guys will be like, I like chapter 1. This is good. Long division happens with any type of polynomial dividing into another polynomial. They can be linear and they can be quadratic, okay? So if I'm dividing and my divisor, the thing on the outside that's going in, if it's linear, I can use long division. If it's quadratic, meaning it has an x squared in it, I can still use long division, okay? So long division is like the foolproof, it works every time. Synthetic division is strictly when your divisor is linear. What do I mean by that? X plus 3 is linear. X minus 8 is linear. Notice I didn't say squared in there. So synthetic works linear only, so there's kind of a catch to that. And then long division works when you have divisors that are not as pretty. Okay, so there are two options that we're going to be able to use. They'll never tell you, you have to use long division or you have to use synthetic. You can be cognizant about which one you want to use. However, you should know how to do both. Okay, so we're going to start with something pretty simplistic. So I'm going to tell you to divide x to the third plus 2x squared minus 11x plus 6 by x minus 2. Okay, we're going to start by doing long division so you can see it. I'm also going to do synthetic division with this one because I can. Why can I? Because my divisor is linear. It's x minus 2. Okay, I'm going to show you both. The first thing I do is I scan my eyes across the things that are both my divisor and this thing here. I can't remember the name for it right now. So I look at it and I say, do I have every exponential power there in some shape or form? So my highest exponential power there is x cubed. So I better have every one below it available. I have x cubed, I have an x squared, I have an x to the first, and then a no x. If for some reason I'm lacking one, so for example if x squared is missing, I'm going to actually place a placeholder in. I'm going to put 0 x squareds if I don't have any. Does that make sense what I said? This one's good to go. If I look at my divisor and I look at that and I say, okay, do I have all my my exponents available? I do. It's x to the first and then no x. I'm good. Are we cool? So sometimes you have to put placeholders in. So we're going to do long division. We're going to take x minus 2 and we are going to divide it into x cubed plus 2x squared minus 11x plus 6. Have you guys done this before? A long time ago, algebra 2-ish? Okay, okay. I'll tell you my brain, my thought process while I do it, just you have it. But if you feel comfortable, jump in it and do it. I'm going to tell you the way I think is I have two things and the divisor has to go into two things. So my first answer is going to be above the second guy. So then the first thing I do is I take this first thing of the divisor and I say x to the first times what is x cubed. So x times blank is x cubed. So what is it? X times what is x cubed?
X squared.
X squared. So that is what's going to go up here. So then I actually check myself by multiplying that answer up there, and I multiply by each of the components. X squared times x is x to the third. X squared times negative 2 would be minus 2x squared. Put a line and then subtract the whole thing. Why did I put parentheses around what I'm subtracting? Because that negative has to distribute through. So ultimate goal is to get rid of the first component, which happens if I did my multiplication right. X cubed minus x cubed, good, they're gone. 2x squared minus negative 2x squared will become 4x squared. So I take that, bring it down, and then drop down the next term. Are we cool? Then my brain does the same thing. X goes into 4x squared. In other words, what do I multiply x to get into 4x squared? So 4x's. So positive 4x's. Sweet. I take the 4x and I multiply by both of those components. 4x times x is 4x squared. 4x times negative 2 would be minus 8x. Put parentheses around the whole thing. You're going to subtract that. The good goal is I got rid of the first thing, which is what I had to do. And then I take negative 11x plus 8x. So I get negative 3x. And then I bring down the plus 6. Are we good? Have I lost anybody? Are we comfortable? Sweet. Now I'm going to take the x and I'm going to say x times what is negative 3x? And you're going to tell me it is?
Negative 3.
Negative 3. So minus 3, multiply that out, subtract parentheses. When I do negative 3 plus 3, I get 0 x's. And then I get 6 minus 6, that's 0. That thing that's down there is what we call our remainder. Cool? So my resultant is this guy right here. That's the answer I'm looking for. Are we cool? We've seen it. We could kick it. We got it. Okay, synthetic division. Have you all done that before? Yes, some of you? It's been a minute. I don't remember how to do it. Okay. So what I'm going to do is I'm going to take the divisor, x minus 2, and I'm going to set it to 0. If I set it to 0, what does x equal? 2. So I'm going to take the number 2, and I'm going to make the house upside down this time. So this is synthetic division that I'm doing now. The reason why I can do synthetic division is because it's a linear factor, right? I'm going in. So I'm going to take the coefficients. What do I mean by the word coefficients? The numbers in front of my x's and like that stuff, right? I'm going to take those guys and I'm going to write them out, not the x's. So what is the first thing in my divisor there? In my dividend? What's the name of that? I don't know. What is x? What is it? Thank you. So what is in front of x cubed? A 1. What's in front of 2 and x? I said it. What's in front of x squared? A 2. What's in front of the x? Negative 11. What's in front of the thing that doesn't have an x? A 6. So literally I took the things that were there that are the numbers that fall in front of the x's or the x squares or the x cubes. So are we cool with how I found my numbers so far? Okay, so step 1 for synthetic division. Drop the first number down. Drop it down. It must be a song that goes with it. Or a dance. I'll figure it out. Drop it down. And then the second step is to multiply the divisor times that number. So 2 times 1 is 2, and I'm going to put it right here. Drop it down, multiply. Then you're going to add. So you add those two together. So plus 4. And then multiply. Do, do, do. What do I get when I multiply? I get an 8. And then I add. So what do I get when I add? Negative 3. And then I multiply. And what do I get? Negative 6. And then I'm going to put a little box because what is left is what we call our remainder. I think the hardest part of synthetic division is to figure out what my final resultant is going to be as far as exponential powers. And I got to think of it this way. I'm dividing x to the first into x cubed. So I'm bringing it down a notch. If x first goes into x cubed, I'm doing 1 less. So what's my answer going to start with? An x squared. So my answer is going to be 1x squared plus 4x's minus 3, which is the same answer I got up there. What do you think? Good? Yeah. When's the only time I can use synthetic division? When my divisor is linear. That's so pretty. All right, let's do another. Okay, I'll put it up here for you to do. There you have it. Are you going to choose to do long division or are you going to choose to do synthetic is your first choice and then set it up? Can I erase this guy over here, the synthetic that I did? Are we cool? Who's choosing synthetic? People after my own heart.
We have to do a 0 for the x squared.
Correct, because you're lacking. That's why I put this one up there, just to see if you were listening to my melodic voice. like math music. You guys, I'm surprised I don't put you to sleep. How do we feel about it so far? We're good? Good, good, good. All right, how's our math looking? Are we good with our numbers down below there? Did we get 2 and then -6 and then 17 and then 1? So what does that mean about my remainder? What does that mean about this thing? Is it a perfect divide? Is it factorable? It's not a good factor because I do have a remainder. When it turned out 0, I was good to go, okay? So this tells me I have a little hiccup in there because I have a remainder. How do I write that out? Remember the old days where we put big R and then a 1? Yeah, we can't do that anymore, unfortunately. So we have to figure out, we started with a cubed, we divided by x to the first, so my resultant is going to have what exponential power? Squared. So this is 2x squared minus 6x's plus 17. And back in the day, we would have put a big R and then a 1 because that was our remainder. However, we're going to say the remainder is a positive 1. I have a positive 1, but it's actually continued to be divided by the divisor. So it's plus 1 over whatever the divisor was. In this case, it was x plus 3. So that's how I write my remainder. Good? I haven't scared anyone yet, right? A-levels, you're gonna like A-level. You're gonna like A-level. I mean, I think. I say that, but I feel like. Okay. Okay. Are we feeling okay? So let me tell you, if something is, I told you this a second ago. This is what I'm gonna tell you something called the remainder theorem. Okay? So the remainder theorem is actually kind of cool. The remainder theorem says if my remainder is a 0, that means the thing that I started to divide by is indeed a factor. Okay, does that make sense? So for example, if I took x minus 2 and I wanted to divide it into x squared minus 4, is that indeed a factor? Well, can I do it as a divisor? Can I divide it like this? What am I missing if I have x squared minus 4? Plus 0 x's, right? So I would have plus 0 x's, and then, did I say minus 4? We know that x squared minus 4 is x plus 2 and x minus 2, so we know x minus 2 is a divisor. So it's kind of like a moot point for me to go through the process. But the remainder theorem says if my resultant at the end is 0, it was a factor. So oftentimes what this leads to in ACE Math is it's going to say factorize completely, which means sometimes they are really nice, really not so nice factors. Like I can't just unfoil them like I want to. So oftentimes we resort to taking and using long division. If we long divide and what we have left on top, if our remainder turns out 0, yay, that was factored. Does that make sense? So we're going to use this thought process that if my remainder turns out 0, I've started to factor this thing. And it's a lot easier than me figuring out how to unfoil it because it's cubed and I can't. Okay, so what we're going to do here is a problem. The directions read, use the factor theorem to show that x minus 3 is a factor of x cubed plus 2x squared minus 16x plus 3. So how do I show, using the factor theorem, the remainder theorem, kind of interchangeable, how do I go show that it is indeed a factor? So how do I attack that? I divide it, and if my remainder is 0, it's indeed a factor. How shall I divide it? I would use synthetic. How come I can use synthetic? Because the divisor is x to the first. You guys feeling good? Must be a good looking teacher today. Today I brought my beauty. Are we feeling good? Okay. Was it good? We good? We showed by the remainder being 0 that is indeed a factor. Are you cool? Okay. I love it when we're cool. Okay, now let's think about Cambridge type of question here. Okay, 3x squared plus 5x plus, minus 2. Okay. I'm going to say given that this is a factor of I have to talk to you about a little something before we do that one though. Before we do this one, I want to talk a little bit about something. Tell me when y'all are cool. We'll do that. So, if I know something is indeed a factor, right? So that means if I divide it in, my remainder is 0, right? So that means it's nice, it comes out pretty at the end. What's going to happen if I took, like this remainder of this guy here? We proved that it was a remainder. What if I took 3 and I plugged it in to this original equation? What's going to happen? Let's kind of test the waters and see. So 3 to the third, right, plus 2 times 3 to the second, minus 16 times 3 plus 3. Can you calculate that out for me? Because it was a factor. So I want to see what happens when I stick a factor in there. What do we get? 3 to the third is 27?
0.
Oh, we get 0. So 27 plus 18 minus 48, thank you. So 27 plus 18 is
45.
45, plus 3 is 48, minus 48. Oh, it does. It's really cool. It comes out 0. Should it?
I'm gonna go with no.
Go with yes. Because it isn't a factor and it doesn't produce a remainder, it should produce a 0. If it wasn't a factor and I plugged it in, what would it produce? The remainder. It would produce the remainder. It's called the remainder theorem, factor theorem, yes.
So could you do that instead of solving with division to prove that it is a factor? And
Yes, absolutely.
Okay.
So you can show, well, here's the deal. Yes, I think that's sufficient for a resultant. I think you could say, look, if we're showing it's a factor, if I plug in the 3 and it pops out a 0, I know for a fact that is perfect. So yes, I think that would work for me every time. Now the question I have is, this guy over here, I have 3x squared plus 5x minus 2 is a factor. I'm telling you it indeed is a factor, okay? And then I have, it goes into this, but I have some obscurities here. I have an unknown of A and an unknown of B. Are you guys feeling what I'm saying? So we have to think like Aice-like, and we have to figure out how in the world am I going to tie what I just showed you into working this problem over here. So do you guys agree with me that the divisor I have over there is not linear, it's not pretty, right? It is 3x squared plus 5x minus 2. Potentially though, could I make it pretty? Is it itself factorable? Does that make sense what I just said? So what would it be if it was indeed factorable? Let's try this and see. So we have 3x squared plus 5x minus 2. Is it indeed factorable? Hopefully, because this would make our life really, really easy. How do we factor this? If for some reason I don't know how to factor, disclaimer is that we can use the what? Yes, for sure. Quadratic formula is still our friend. So 3x and x, I'm gonna go on a limb and say I think I'm good. Check my math. 3x squared, 6x minus 1. Yes, I'm good. So I took this quadratic, this square, and I broke it into two linear factors. So tell me what you know about these two linear factors when we're talking about that guy over there. Okay? What's the first linear factor? Just go out on a limb.
Do they both fit into it?
If I put one in, what will its resultant be if I stick it in there?
Should be 0.
It will be a 0. Why? Because it told me it is a factor. So if I stick 1/3 in, what shall its output be? 0. If I stick -2 in, what should its output be? 100%. So let's see what happens if I do that. I got 3 times 1/3 cubed plus 17 times 1/3 squared plus a times 1/3 plus b, and what will it equal to? Yeah, 0. Good. Okay, that's okay. And if I do the same thing with the -2, what's going to happen? Ah, I heard it.
Oh no.
What'd you say? Why would we have to solve simultaneously? Because we're going to have two equations with two unknowns. This brings us back to what we learned last year. You have two equations. They're not going to be beautiful. I promise they won't be beautiful. However, the first equation is going to be in terms of a and b. And then the other equation is going to be in terms of a and b. What are the three different ways that we can solve simultaneously?
Solve for A and plug in.
Substitute, solve for a, plug it in the other. What's the other way? Elimination. And what's the third way? Yeah, I never do that. You shouldn't even expect it to be one of our options, but I have to, to be a real math teacher, I have to say that. Okay, so, this is fun. No? This is an example of what an ACE question would look like on paper 2/paper 3. This right here, the way you reason through that, I like this stuff. This is not like a hill that's hard to climb. Okay, so we just have a lot of math to do. 1/3 to the third. So 3 times 1/3 to the third, that's 1/27. 3/27 is 1/9. Okay, 1/3 squared is 1/9, so 17/9 plus a/3 plus b is 0. What am I going to do? Because I'm really frightened by fractions. Those of you that know me very well, what will I do next? Everything by 9. Yeah. Why would I multiply everything by 9? Because I don't want to have fractions. Don't like them. So if I multiply everything here by 9, what do I end up with? 1 plus 17 plus 3a's plus 9b is 0. How do you feel about that? Isn't that much more pleasant to look at than this guy over here? Yeah. So we have 3a plus 9b's, that's 18, right? Equals -18. Ooh, what can I do even more? Divide everything by? I would as well. A, divide by 3, divide by 3, divide by 3. A plus 3b is -6. Equation number 1. It's like an infomercial. And there's more, right? We have to keep going. So we have 3 times -8 plus 4 times 17. 4 times 7, yeah. What is 17 times 4? 28. 68. Minus 2a plus b is 0. 3 times -8 is -24 plus 68 would be 40. Am I right? So -2a plus b is -40. Check my math. Yes. And then everything, no, there's no divisibility there. So we got what we got, right? So now this is equation number 2. And again, like the bad infomercial, what do I do with those two equations? I would, yeah. You could solve for a in one, stick it in the other. You could line them up and do method of elimination. Is my math wrong?
Is it 44? No.
Is it? Instead of 40?
Yeah.
Thank you. I was so confident too. How is that for you? Negative 44? That makes it even uglier. Thank you. You don't have to whisper, just say, Miss K, you didn't add right. Your calculator had a malfunction. Because it always has a malfunction. There is absolutely not a day that the malfunction does not occur. It's negative 44. What is 17 times 4? 28. What is this guy here? 24. That's why. Thank you. The 8 just came into my head. Okay, now what do I do? Are you eliminating or are you solving simultaneously with substitution? Substitution. All right, I'll roll with it. A is equal to negative 6 minus 3b, whatever. You guys are going to get the same answer, probably better than I do. Oh, you're making me work for a living over here. What is negative 44 minus 12? Negative what?
Negative 44 minus 12 would be negative 56.
Oh, negative 52.
56.
Are you getting that answer too?
Yes.
Thank you. So B is 56 over 5. Check my math.
It would be
Oh,
7.
that's positive 6, and this is a 7. I'm going home. Am I allowed?
Yes,
Can I really?
sure.
You're causing me stress. Because I keep thinking I'm doing it wrong.
It's me. I can't add today. Listen, it's been summer. I'm in summer mode still. It's okay, right?
I had a Starbucks coffee. I was on fire today.
I was. That doesn't mean my brain is on fire. That's just my body is going good. Okay, that's nice. It turned out better than 56 over whatever I was looking at.
It's negative.
I'm stressing you out. I'm sorry.
Because I'm like, there's no way I'm that rusty. Like, I can.
But I am. That's the problem. I did summer school too, although that didn't really use a lot of brain capacity. 18, 24 minus 6.
Yeah, 18.
Well, I should just completely.
I just couldn't. I was just like, too much geometry. Who really? I'm just gonna be honest. Geometry is it really a math? I don't
It's
know.
stupid.
Okay, thank you.
Sorry.
I know all these kids are like, can you help me with? I'm like, yeah, I could try. All right, so are we good? What do you guys think of this? Except for the fact that I don't know how to add and subtract anymore. I should invest in a calculator.
I feel like there's so much room for error because there's so many.
Because you can't divide like Miss K, I get it.
No.
I get it. Okay, so here's the deal. We'll freshen up on, I have lots of homework problems. I will be on.